Good evening, friends. Welcome to 360DigiTMG. Today we are going to understand about DistilGPT. Okay. So here, firstly, we'll discuss about what is DistilGPT is all about. Okay. So this is a one model, which is a natural language processing model. It is implemented by using a transformer architecture. Okay. Generally, we are using the Python programming language for implementing this model. DistilGPT-2 is a short for distilled GPT-2. Okay, so it is an English language model which has been trained with the supervision of smallest version of generative pre-trained transformer. Okay, generative pre-trained transformer 2, that is GPT-2. Okay. So we'll have a smaller version of GPT-2 that is called as what? Distilled GPT-2. So distilled meaning light version of the model. Okay. So we have a version called GPT, which is trained on, which has an architecture of transformer. Okay. Which is following the architecture of self-attention mechanism and transformer architecture. Now, if we want to use a lighter version of GPT-2, we'll have distilled GPT. Okay. So we'll discuss about the model details. So this model is developed by Hugging Face. Okay. Now, Hugging Face is a company wherein we'll have open source model. We'll have open source model, multiple open source models are there. Okay, we can use this model and we can use it for our own purposes. Like we can use it for text generation or language translation, or what we can use it for, image to text. We can use it for several applications are available. Okay. And since it is open source, people can directly take an API key from there and they can use it. Okay, so DistilGPT-2 is a English language model, which is pre-trained with the supervision of 124 million parameters, version of GPT-2. Okay, so GPT-2, which has been trained on 82 million parameters, which will be taken the reference of GPT-2, original GPT-2 model. Okay, by using which thing, there is one thing called as knowledge distillation. What is knowledge distillation? How we're going to use this bigger version into smaller compressed version model? We'll understand that. Okay, so knowledge distillation and was designed to be a faster and lighter version of GPT-2. Okay. So what are the key characteristics? So it is a transformer-based architecture. Okay, it adopts the transformer architecture, which has proven highly effective for language processing task. Okay, so after that we'll have distilled from GPT-2. We have already understood about what are the transformer architecture. We have all these things in our previous lectures. You can go through that. Okay, so we'll have distilled from GPT-2. So it has created from a process called knowledge distillation. Okay, wherein what will happen? We will create one smaller model which is trained to mimic, and behave like a larger model only. Okay, the larger model, which is a GPT-2 model, which is trained on very big parameters. Okay, which has been trained on very big parameters, as well as it will have complex architecture also. Okay, so what DistilGPT-2 will do, it will use that model, and since it has been, the DistilGPT-2 is trained on lesser parameter, so it will try to take some features, it will extract some features from a GPT-2 model and try to behave like a GPT-2 model. Okay, so what it will do then, what are the different advantages of this? It will be like, it will do fastly. Okay, it will be faster as compared to that of the GPT-2. Okay, it will reduce the size as well as computational cost. Okay, if we will have a fewer layers and parameters compared to that of the GPT-2, making it more efficient and suitable for devices with limited computational resources. Okay. And the second thing is it is smaller. DistilGPT-2 is a smaller as well as it is faster. Okay. So DistilGPT-2 is a smaller and faster versions of GPT-2, making it easier to deploy and use on devices with limited resources. Okay. Where there is limited resources, okay, like our mobile phones and other things, where we'll have a small data. Okay, at that time we can use a small, to deploy this model we have to use a smaller model. Okay, so this model can help. It is only 40% of the size of GPT-2, but it still retains most of its capabilities. So how it will do, what is the thing behind this, we'll understand. Okay, so there is one thing called as knowledge distillation. Okay, knowledge distillation. We use the knowledge distillation. It is a technique that allows a smaller model to learn from a bigger model or a larger model. Okay, this means that DistilGPT can achieve similar performance to that of GPT-2 on a same particular task. Okay, even though it is smaller also. Then we'll have fine tuning. DistilGPT-2 can be fine-tuned for specific tasks. Okay, if we want to use it for question answering, if we want to use it for summarization, okay, like various other tasks. If we want to use it for question answering, summarizations, text to image, image to text, likewise, if we want to do, we can use it for fine-tune. By using fine-tuning techniques, we can use it. This makes it a versatile tool that can be used for varieties of applications. Okay. So it has multilingual, means DistilGPT is available in varieties of languages, including English, French, German, Japanese, okay, Spanish, and Chinese. This makes it a useful tool for tasks that requires working with multiple languages. Okay, if we want to use it for machine translation from one task, from one language to the another language, we can use it for that purpose also. Then the most important thing is it is an open source. Okay, so DistilGPT is an open source model, which means it is freely available for everyone to use and modify as well. This has made it a popular choice for researchers and developers who want to build their own applications using LLMs, large language models. Then language translation. It can be used for language translation task, where the model can generate translation from sentences or paragraph from one language to the another language. Okay, it can also be useful for code generation. Okay, DistilGPT can assist in generating the code snippets based on the natural language description, making it useful for developers. Okay, so these are all the key features of the DistilGPT-2 model. Now, this is the architecture. Okay, consider this as your GPT-2 model. Okay, and this is your DistilGPT-2. Okay, so this is a complex architecture, or it has more parameters where this GPT-2 has trained on. Okay, by using this technique called as knowledge distillation or knowledge transfer. Okay, we will like there are compression techniques. Okay, we'll apply that and we will make this model into some smaller model, so that the most important features from this model should retain here. Okay, so this is the architecture behind this DistilGPT. It will behave like a teacher-student architecture. Okay, whatever the teacher knowledge it have, student also have the same knowledge, but it has some limited knowledge. Whatever important, it has that knowledge. Not the everything, but it has sufficient knowledge, which whatever the question will be having here, user will ask, it can able to answer that questions like this. Okay. Then we'll have architecture explanation. In this case, the base model is a teacher and the distilled version is the student model. So we train the basic model to understand its weight, and then we'll distill the knowledge to the light versions. Okay, we'll distill this knowledge into some lighter versions like teacher and student. Okay, we the smaller network should mimic crucial weights from the larger network. Okay, while the base model minimizes the errors with the true labels. So distill training will continuously aims to minimize the error with both the real label as well as the base label predictions, base model predictions. Okay, and whatever the losses will be, there will be losses that losses will be distilled errors as well as the losses within the means there will be losses with respect to whatever the teacher model will have and the student model will have. The variation between these two, the difference between these two predictions, that will be the difference between these two predictions, that is one loss, and whatever the loss which is there in the input and the output from the distill model, that will be again one loss. So there will be two losses here. Both the losses will be added together and then we will form the error. Okay. While GPT-2 has 1.5 billion parameters and 24 layers, the DistilGPT-2 has 6 layers and 82 million parameters. Okay. The word embedding size for the smallest GPT-2 is 768 and DistilGPT-2 has same embedding size of 768 as well. Okay, both will have the same embedding size. Then what are the applications of DistilGPT? What purposes we can use this? So since this DistilGPT-2 is a lighter version of this GPT-2, it is intended to be used for similar use cases, okay, with increased functionality of being smaller and easier to run the model, the base model, than that of the base model. These are most use cases. There is first is text generation. Okay, we want to use it for some text generation. We are giving some images and we want for this image to write one text for this. Okay, so we can give one point and from one point we can have multiple text generation related to particular topic. Okay, like we can use it for chatbots, okay, which are very trendy nowadays. We can use this, we can take a Hugging Face API key and we can bring one, we can use one chatbot, okay, for particular purposes. Whatever the purpose you want, you can use that. And then we'll have machine translation. Okay, for machine translation, if we want to use it from one language to the another language, okay, since we already know this, GPT-2 is also can be useful for different languages. If we want to use it from one language to the another languages, we can use this. So these are all the applications of DistilGPT. Okay, so now the steps to involved in working with DistilGPT, how we can use this actual working. So there will be a data collection and pre-processing. Okay, so we'll understand all these steps: tokenizations, model architecture, training, evaluation, and deployment. So our first step is data collection and pre-processing, wherein we will collect our data. Okay, and data will supposedly from the textual format. That is why we are using this LLM, natural language processing and large language modeling. Okay, large language models. Okay, so our data will be unstructured and textual data. And the data sources can be from anywhere. Like it can be from web scraping, from books, articles, social media conversations, so on and so forth. Okay, volume. It can be a billions of words. Okay, and quality. It should ensure diversity in the words, relevance, and it should not be biased towards certain things. Our data should not be biased towards certain thing or certain cases. Okay, so that is the quality. That should be the quality. Then pre-processing the text. So in the pre-processing text, we have cleaning. We'll remove noise, errors, and inconsistencies within the data. Then we'll do the normalization. We'll convert the text to smaller cases, handle the contractions, etc. After that, we have tokenizations. We will split the text into individual words or subwords by using word piece, token embeddings, or sentence embedding. Likewise, we have different tokenization techniques. Here we are using, suppose, word piece. Then the next thing will be tokenization. We'll use and we'll assign a numerical identifier for each word or each subword. Okay, for each word or each subword, we'll give some unique numerical identifier or unique tokens. Okay, then we'll map. We will create a mapping between tokens and its numerical IDs. Okay. After that, we will have model architecture. Here we are using a DistilGPT architecture, which is based on our GPT-2 architecture. Okay, so it is nothing but a compressed version of our GPT-2. Okay, DistilGPT is nothing but a compressed version of our GPT-2 model, which is trained on fewer layers for making a faster processing for low computing devices. Okay, so here we'll have decoder only, like it is designed for text generation. Okay, so here the key components will be in the encoder state. We will take our inputs. Okay, what we'll do in the architecture is we will take our in the encoder state, we will have, suppose, input. The input will be fetched from the encoder layers. After that, we will use our attention mechanism. Okay, within our attention mechanism, we will have multiple inputs. Okay, we will take multiple inputs, we will form our alignment scores. Okay, within the alignment score, whatever the alignment score, okay, with respect to whatever the alignment score is, we will give the importance score. We will form the importance score. Okay, after getting the importance score, we will take that importance score, whatever the importance score, we will find that that is relevant, that is important, which is having more important score. Only that part we will send it to our further feed forward networks or feed forward layers, wherein we will concatenate each and every inputs which are having more important scores. We'll concatenate all the things and then we will send it to a decoder. Decoder will again fetch the input and one by one to one encoder, one text, it will form one token. And again, it will give it for one token. If we are using it for language translation, then for one token, for one input, whatever the output has been generated, whatever the important score has been generated, that will be sent to the decoder. Then decoder will decode that text and then it will be sent to the output layers. Okay. So this is how the architecture behind this. Okay. So this is called as a transformer architecture, wherein our encoder will take our input text. Then it will send it to our attention layers. Attention layers will allow the model to focus on the relevant parts. It will not focus on all the parts. It will focus on the relevant parts. How the relevant parts are identified? By using the alignment scores and the importance scores. Okay, after getting the alignment scores and the importance scores, we will feed forward network. What will feed forward network will do? It will feed and all the layers, all the input layers, it will send it to the upper layers. Okay, it will concatenate all the layers, it will concatenate all the inputs and it will send to the another encoder layer. In the another encoder layer, what will happen? Another new text will be there. Okay, another new text will be there for the next encoder layer. There will be new input again coming. For that new input, again this process will be there, alignment score, attention scores and other things. Again, it will feed forward network will feed forward that and concatenate all the things and it will feed further. So feed forward network is basically used for all the encoder layers, adding all the encoder layers together. Okay, concatenating them, feed forwarding them to the decoder layer. That is what the process for the feed, that is the meaning for the feed forward network or feed forward layers. Okay. So this is the architecture. Then we'll have training. So the training means we will teach the model to predict the next word in the sequence. Okay. So what is the process for that? So we will feed the model with a large corpus of text. Okay, large corpus of text, we will feed our model. Okay, like whatever the data set or whatever the database we will have, we are using there all the big corpus, like we have already understood whatever the data size will be. Okay, so we have already trained our model into large amount of data set. For each word, we'll have masked the next word. So here, sometimes we use masking that is called as static masking. Sometimes we use dynamic masking. So likewise, we used. For why we use this? So that masking is used generally for our model should not get overfitted. Okay, that is why we use masking. Within our training data set itself, we will do the masking. Sometimes for some model, we will do static masking. Static masking means within the sentence, we will mask some portions and like within one input, we will mask only one word. Okay. And dynamic masking means within one sentence, we are masking multiple words. That is called dynamic masking. And then our model should able to predict that word. Our model should able to predict that word, whether that masked word is what, with the prediction score. Okay, 90% or 99% chances that this word is Paris or this word is something. Or whatever the word is, whatever the mask word is. So then after that, what we will do? We will compare the predictions with the actual next word. Okay, with the actual word. We will compare the result with whatever the actual word is with respect to what our model has predicted. And then we will adjust our model parameters to minimize the errors, prediction errors. This is how we can use it for next word predictions. Okay. So likewise, we can use it for text generations. Likewise, if we want to use it for summarizations, if there is very long sequence of data, if we want to use this model for text summarizations, we can use this and make a model summarize that. Okay. So how to access the evaluation? How to evaluate our model, whether our model is good, bad, or moderate likewise. Okay, so access model performance on various tasks like text generation. If the model has evaluate fluency, coherence, or creativity. Okay, so these are some of the things that we have to focus. Then there is if the model is used for machine translation. So what is the evaluation accuracy and fluency? Whether it is giving accurate pronunciation to that word or not. What is the accuracy of this model? Likewise. Okay, if we are using this model for question answering, we can evaluate it for ability to provide correct and relevant answers. Okay. Then we can use it for summarization. If we want to evaluate accuracy as well as preciseness, we can use it for that purpose also. Then deployment. Okay, so as we have evaluate our model performance and we are satisfied with the model performance, then we want to deploy that model. Okay, so make the model available for use in applications. Okay, then there is APIs, Application Programming Interface, which allows integration into websites and softwares. Then we'll have cloud services, which will offer to model on cloud platforms. Okay, we can deploy a model on cloud platforms, or we can create one API keys, okay, which will allow to integrate with websites and softwares also. Then we can use it for mobile applications, desktop applications, and various multiple applications, web applications. For multiple applications, we can use. We can integrate our model for offline users also. Okay. Then what are the different considerations? Okay. So consideration is hardware requirement. Ensure sufficient computational resources we have. Okay. Then latency, which will optimize for real-time responses, and privacy and security. Like if we are using it, it should have the protective. Our data is very important, right? So it should protect the sensitive data. Okay, so this is all, guys. We have understood about what is DistilGPT, how DistilGPT is used. Okay, it is a smaller versions of GPT model. Okay, wherein we are compressing that model so that we can use it for lighter versions. Okay, then this is an open source model, okay, which is trained on lesser number of parameters. Why we have used it by using a knowledge learning, knowledge distillations, okay, like a teacher-student architecture, likewise. Okay, so these are all the key features we have understood about the architecture. What is the architecture of teacher as well as student? And here I want to mention this. Here we are using a transformer architecture. Okay, and here in depth we have understood about what is a transformer architecture is all about. Okay, so here these are all the steps related to how to train the model. For that, we can use it for data collection and pre-processing. Then how we'll do the tokenizations, model architecture, okay, training, evaluations, and then at last deployments. So this is it, guys, for today. We'll connect with a new topic on next Saturday. Okay, thank you for joining.